Hey there, everyone. My name is Ryan Schul. Welcome to my analytics channel. I'm strongly considering evolving from data science and machine learning into more general analytics because as time has gone on and I've been pursuing this journey, creating videos on average about one per day for almost a year now, I feel like, oh, maybe it's just time to, just, I don't know, get more mature and kind of go in a slightly different direction. Still, you know, discussing data science topics and machine learning and things like this. But there's so many things out there. I think I need to branch out and just diversify a little bit. So it might become more general analytics, but that remains to be seen. We'll see what happens. That we'll see where it goes. So for the topic today, I want to talk about retrieval augmented generation. This is a new buzzword now. It's becoming quite popular, and there's all kinds of folklore around that. So I want to dispel any misunderstandings or any disbeliefs or something and clarify a few things too. So RAG is kind of like an LLM. An LLM is a large language model, which is trained over like millions, hundreds of millions, maybe billions of different feature sets. And all of this is taken and distilled into the computer's memory. It assimilates all this information and regurgitates it when you ask it questions, right? And it gives you responses and tries to customize its response based on your interaction with the system, right? So everything is basically trained on public domain books, anything from the Bible to Wikipedia. RAG is a little bit different. It's really trained on your own personal proprietary data sets, your internal PDFs, your internal databases, your internal emails and SharePoint and PDFs and Word documents and things like this. LLMs have general knowledge and ability to create and write. You can engage in Q&A sessions. They have code generation, math help, trigonometry, imagine, geometry, algebra, calculus, things like this. It can do all kinds of wonderful and amazing things. RAG is similar, but it's more grounded on answers based on your specific documents in your system, in your environment. Okay, so it learns based within your ecosystem. LLMs work out of the box. No extra data set is required. RAGs require retrieval systems, such as vector databases, search indexes, feature relevant information. Again, think about Word documents, PDFs, things like this. And LLMs explain how a neural network works. Or it's a little bit like a human brain. You learn things by association, by repetitive conditioning, right? Things like this. And RAG is more like summarizing the internal quarterly reports, the information in your documents, the personal information about your enterprise, about your company, about your corporation, things like this, right? So an LLM is really a smart assistant, almost like an SME or subject matter expert. That's an expert on everything, any kind of topic you can imagine, right? A RAG is similar in terms of the way that it assists people, but now it can actually relate to your company's specific files, right? Your enterprise emails, your PDFs, your SharePoint files, things like this. So any document that you upload to ChatGPT remains in ChatGPT for that specific session. It's private, it's secure. Nobody is supposed to get access to this data. Now, if a hacker, somehow cracks into the system, maybe they can get access to it. But supposedly, the documents are purged after the session is complete and ended, and any interaction you had with that system is deleted. So it does seem pretty secure, pretty stable, pretty confidential, which is great. But again, the main difference between LLM and RAG is the RAG just looks at your system. There's nothing exposed at any point in time whatsoever, right? So it's totally personal and completely confidential. So in my notes, I have the features of ChatGPT is really public data from the web. It's constantly being trained and updated, although there is a cutoff point. Like for the current ChatGPT, I think it is either April 23rd or June 24th. That's what I found based on my research. And only what has been written and documented and captured by the system up to that point in time is stored in the LLM's memory. So anything that happened last week or last month just isn't there. This doesn't exist because there's a cutoff point, right? So this limited content that has been exposed to the LLM, right? On the reverse side with RAG, your private documents are scanned on your system, right? It's never exposed externally in any way, shape, or form. And any updates that you make, the RAG is going to pick that up, right? So if you have a new document that's dumped into a SharePoint folder or dumped into a network's share drive or something, that is going to get picked up by the RAG. If it's yesterday, last week, last month, um, doesn't matter, right? It's going to be picked up by the RAG almost instantaneously. With the LLM, it's not, right? Like you would have to upload those documents and get any kind of refreshed, updated documents in not embedded, but exposed to the LLM for it to understand what's there, right? With the RAG, you have full integration with local secure cybersecurity. You're behind the firewall at all times. Nothing is exposed whatsoever, and it's highly customizable, right? You can plug in your own PDFs, databases, emails, and so on and so forth. So I have a couple more notes down here. You can look at that at your leisure. Let's jump into this and see what this bad boy can do, okay? So I have some documents here. Doc 1, overfitting occurs when the model learns the noise in the training data. So this is some information about machine learning. Document 2, precision is the number of true positives divided by the number of predicated positives. Okay, again, ML terminology here. Gradient descent is an optimization algorithm that uses a minimum loss function in ML models. And number 4 here, the bias variance trade-off is a key concept in supervising learning. So I just have some very basic foundational fundamental concepts here relative to machine learning. I am looking at this model right here. This is a mini LM L6 V2, and this is a sentence transformer. So if you want to get more information about this, you can go over here, google.com. You have a whole bunch of models, HUGGING, Hugging Face models. I think they're up to 1.8 million now, so it's pretty sensitive and pretty comprehensive. Let's see what it comes back with. 1.8 million. So 1,837,703. You come back tomorrow, I'm sure it's going to be more. These are increasing almost constantly throughout the day, every day, right? So 1.8 million models that you have available to you. Now you have to understand what you're trying to accomplish here. If you're training a RAG model on documents and the corpus of text, the body of text that exists on your hard drive or on your corporate network drive or in your enterprise system somehow, somewhere, databases, anything behind the firewall, anything that is exposed to your corporate constituents, your employees, people who work for you, this RAG will have access to all these things, right? So we are going to use this model to go ahead. This is a pre-trained model. Go ahead and ask this model questions based on information that has been pre-trained on. So all these models have been exposed to different things, either images such as cars, boats, cats, and dogs. This would be an image recognition type of classifying model. You can have regression models. You can have models that have learned cooking recipes, drink recipes, right? How to make mixed drinks. Models that have been trained on history. Models that have been trained on science and math and architecture and engineering. All these models have been pre-trained, or you can take a fresh model and train it yourself. I like these pre-trained models because they're very fast. It's already been trained. The train has been saved and captured and preserved or pickled. All you have to do is show your information to the model. It already knows how to identify whatever it is you're trying to identify, right? So it's been trained on that thing. So you can go ahead and create your own chat GPT key. If you go over here, now this was not working for me earlier today. Let's see if it's working. GPT API key, get your P from OpenAI dashboard. And fingers crossed. Okay, it's working. So it wasn't working, then it was working, then it wasn't, and now it's working again. So you have your ChatGPT secret key over here. You can sign up. I have this URL saved at the bottom of this Jupyter notebook. If you go down here, you'll see that right here. Oh, it actually isn't saved. Let me save it right now. Chat GPT. So it was saved, but it wasn't. So it's a good thing I checked that. So now you have a way to get the Chat GPT API key. You have to download that key or create the key, copy and paste it into the spot right here. Okay. Now I had mine earlier today. I ran the model. I deleted the key or just copied it out and just abstracted this away with this thing right here, your Chat GPT API key. So you get the key, copy and paste it here, and you can do everything I'm doing. I can't expose the key. I don't know how to do the video and not show you the key because you'll get it, but it's personal, confidential. You don't share these things with anybody. So I've already run the model. I'll show the results. I can't run this in real time and refresh it because I need the API key, but you can get that. Go get it. It's free. Plug it in here, copy, paste, and you're good to go. So I'll share all the code with you, right? So you can copy and paste the code and run this in your own Jupyter notebook. So I've downloaded 3 PDF files. I want to expose this to the to the RAG file, the RAG learning model right here. So here's the first one. These are 3 PDF files about the Federal Reserve and how the Federal Reserve operates, what it consists of, how it does business, how it conducts business, and so on and so forth. So these are the 3 PDFs. I gave you the URLs for all 3. You can do anything you want, right? You can plug in any kind of, whoops, that just opened into a new window. I didn't know that was going to happen. That's fine. Here's the 3rd PDF. They're all about the Fed. Again, you can use these examples that I'm showcasing here, or just go get your own. Doesn't matter. When you train the RAG on the contents of the files in this folder, it's just going to learn whatever you expose it to. Okay. So here's the first model. This is Hugging Face. You get your Chat GPT key. Put that right there. Put your files into this folder. And again, it's going to be whatever you want. You change this to point to your files, to your folder on your network drive, on your PC, whatever you want. This is the model that we're using. You saw this over here from Hugging Face, 1.8 million models you can choose from. And if you want a totally different model, by all means, just go search for it, right? Let's say you want one image recognition. I downloaded one of these the other day. Pre-trained model, tested it on a plate of spaghetti. It said this is spaghetti, 99.9% confidence, and 1%, I think it said soup, and 1.01% soup, 0.01%. I forgot what the other one was. It could have been that. It definitely wasn't soup. It wasn't the other one. It was like casserole or something like that. But 99.9% confidence it was pasta, and I was showing that an image of pasta. So those are your models. You expose the model to whatever you're doing, an image. In this case, this is all Federal Reserve material, so it's PDFs that's going to scan through the PDF, assimilate all this information, ingest it, memorize it, and learn from that, and then you can ask the model questions. That's the whole point. So we're going to load data from the PDF file. This can be a PDF, it can be a Word document, it can be a text document, it can be a SharePoint folder, it can be whatever you want, right? PowerPoint decks, whatever you want. Dump all your information into the model. The model is going to learn based on chunks. It's going to join together different words in chunk sizes. The chunks are 500. They have to be relatively small. So you take all these chunks, chop it up into increments of 500 characters, upload that to the model, because you can't upload like whatever, millions or billions of text at a time. It has to be chunked just so it can get into the model, and the model can organize it and make sense of it and interpret it. If you think about it, that's how a human being learns too. You can't take a million lines of text and dump that in front of a human being and say, go ahead and learn this. No, it has to be parsed up into sentences and paragraphs and pages, and you'll scan through that, right? The human will read through this. The machine has to read through it just the same way. You can't load in a billion chunks of data at a time. 500 chunks in a go is fine, and it's pretty fast. So you can do 500, and it's like, okay, and it can do thousands in a couple of seconds. So the number of chunks should be kept small just to be manageable. Well, that doesn't mean it's only 500 chunks. You can get through probably 500,000 chunks in a couple of seconds, right? But you do have to parse it up into smaller bites. So we have all the information here. I'm going to use ChatGPT 4. There's a couple different models. You pay for 4 and I think 4 point, let me see, Chat GPT 3.5 versus 4. Okay, so there's a couple differences here, and I think there's a 4.5. So ChatGPT 4 has more memory than 3.5. 4 can remember more conversations with the user. So it is actually memory aware, or like somehow, maybe that's not the right term. But if you interact with ChatGPT 4, it can remember the whole conversation. You step away for a few hours, come back, and it's going to remember what happened, almost like you're talking to a person, right? It doesn't, it's not like you interact with this tool and then it starts to forget things, or you take a break and go get lunch and you come back and everything that you trained the model on is forgotten, right? It remembers the history of everything too. So you can have a real conversation with this. There's a couple other differences here. Chat GPT 3.5 can access the internet. That's good. 3.5 is free to the public, and GPT-4 starts at $25 per month. Okay, I thought it was 20. I signed up for a $20 plan. Maybe it just changed. If you get on the bandwagon a little bit late, maybe it's 25. But that's it. Like the 3.5 model learns less. It doesn't have as long as a memory. I think it has some memory, but not as long. GPT-4, you pay $20 a month, but much more powerful in terms of understanding, interpreting, regurgitating, interacting with this tool. I think 4.0 is definitely worth the money, whether it's $20 or $25 per month. It doesn't matter. It's totally worth it. So here we are. So I downloaded these 3 files into this folder right here, Federal Reserve, and the 3 files have been ingested into the ChatGPT-4 LLM, and I'm sorry, into the RAG LLM. Now we're not using ChatGPT-4. We're using a different RAG system that's scanning internally on our own system, right? ChatGPT-4 has been exposed to all the contents, I think everything on the internet at this point, but there is a cutoff, right? You saw April, or what was the other, April or November or something? When was the cutoff? April 2023 or June 2024. So anything that's happened after that, ChatGPT wouldn't be aware of it. The RAG, Retrieval Augmented Generation, is aware of anything, even if it came out yesterday, as long as you put that on your network drive or your PC and you point the folder to that, right? This can be the parent folder. You can actually like cut it off here, right? And it can learn everything on your system. I'm going just into this folder and looking at those 3 PDFs. So hopefully that makes sense. I know it's a whirlwind of information here. So here's the query. This is the question we're going to ask to our RAG map model, right? What is the main objective of the 3 reports in the Federal Reserve folder? So here's Federal Reserve. That's the folder. What is the main objective? So I put this into RAG. It comes back with the main objective of the 3 reports in the folder. It names the folder, very convenient. Appears to detail the operations, functions, and the policies in the Federal Reserve System. This includes explaining how the Federal Reserve Open Market Committee, FOMC, makes policy decisions, describing decentralized structure and philosophy of the Federal Reserve, outlining various functions, so on and so forth, initiating stability and health in the U.S. economy. Okay, so that's what it does. And I read the report. I read those 3 reports, just scanning through, not every page. That's exactly right. That's exactly the answer I would expect. Now, who appoints the chair and the vice chair, and who confirms the appointment, and how many years do they serve? So this is a multifaceted question. Who appoints the chair and the vice chair? Who confirms the appointment, and how many years they serve? So we're actually asking 3 questions in one. The chair and the vice chair are of the chair and vice chair of the Board of Governors of the Federal Reserve are appointed by the president. That answers the first question. Their appointments are confirmed by the Senate. That answers the second question. They serve for 4-year terms and may be reappointed to an additional 4-year term. Answers all 3 questions dynamically, almost instantaneously. Very impressive, guys. So now let's ask another question. How many geographic locations is the Federal Reserve divided into? Federal Reserve is divided into 12 geographic regions. And I knew that. That's true. That's absolutely 100% true. And the RAG picked that up, identified it, and created a profile, create a response that's 100% accurate. So what is the Federal Reserve's normalization plan? I read about this. I found one question in one of the documents. So again, pretty impressed. I was pretty blown away. The RAG figured it out. The Federal Reserve normalization plan refers to measures of the Federal Reserve Open Market Committee, FOMC, undertook to return short-term interest rates and the size and the composition of the Federal Reserve's balance sheet to a more normal level. So, right? So it's taking the balance sheet of the Federal Reserve, which is pretty massive, trillions of dollars, and trying to normalize it, right? The plan involves FOMC transparency, laying out its policy, normalization principles, and intentions. As part of this, it's initially planned to raise federal funds from near zero and then normalize the balance sheet and composition. The committee increases target range for the federal funds rate gradually from December 2015 to December 2018. Coffee's out, so I'm going to have to finish this up pretty quick. Apart from this, late in 2017, it began to reduce asset holdings size, slowly phasing out reinvestment of maturing and prepaying securities. By early 2019, the Federal Reserve balance sheet was down to just under 20% as a ratio of nominal GDP. So, guys, that's pretty impressive. I downloaded 3 PDFs, stuck it into the folder, had the RAG scan the folder, read all the contents of those 3 PDFs. I asked it 1, 2, 3, 4 questions, and it got all 4 100% accurate, 100% correct. Okay, so very impressive. very cool stuff here. Here's the paths for the 3 PDFs, but you don't have to test it on this. You can test it on anything, right? Any documents that you have saved, any PDF, any docx file. Um, what else? Like I already alluded to, right? Any kind of SharePoint files, any kind of PowerPoint decks, right? You dump that into the folder. The RAG is going to go through, understand all that, and you can ask any questions you want, and you'll get very accurate responses. So again, the LLM, large language model, pre-trained, uses only internal knowledge learned during pre-training, cutoff dates. Here it says GPT-4 is December 2023. So I think 3.5 was cut off in April. And what was the other date? We have it over here, April 2023 and June 2024. So the GPT-4 has more current information, general Q&A, summarizing, reasoning, coding help, so on and so forth. Higher might make up facts if it doesn't know. So that is one shortcoming of the LLM. It's very apologetic. It's trying to be very helpful all the time. It will almost never say, I don't know the answer to that. It's always going to come up with some response, but it can hallucinate and think that it's actually true when it's not true. And I've heard stories of lawyers using this as, for to try to do legal research. They'll come up with a case that matches, what their plaintiff or their defendant, the side of the argument that they're making, present that to the judge. And I've heard of cases that didn't even exist, and the lawyer referenced a case, and the judge figured it out and said, like, this case never happened. This was imaginary. This was a hallucination from an LLM interaction, right? So it never existed. So you have to be careful with that. Now with RAG, it's a hybrid system that combines retrieval from external data sources, but also looks specifically at your specific documents in your network, right? So on your network drive, on your hard drive, or whatever access you have. If you have files saved on the cloud, it can go to the cloud and reference those, and I digest all the information. Then you ask it questions, and it can regurgitate information, right? Can access custom live data, grounded answers on specific dynamic private data, customer records, legal documents, product manuals, things like this. Lower probability for hallucination. It's really grounded in real data, retrieval just in time. So I think like one of the main benefits of RAGs is it can't hallucinate, or it hallucinates way less frequently than an LLM. So I don't know if it's 100% non-hallucinatory or it's very, very rare, but I've seen LLMs create this hallucination where it gives information that just doesn't exist and never existed. It's trying to be pleasing and be apologetic to the end user, yourself and myself, that interacts with it. But it really should be a little bit smarter and just say, if I don't know, I don't know. It kind of like gets confused or something. Sometimes the RAG, either it doesn't happen with a certain probability or 100% probability, or it's very rare. It just doesn't happen. It's not concerned. And again, RAG fetches internal documents, and it's more secure. It's more like personal than the LLM. And there's no cutoff date. If you have a new document, dump it into your network drive or your hard drive tomorrow and retrain the RAG. It's very fast for the training. It's going to have all the information up to date as recent as you train them all. The LLM cutoff dates, again, it's April, June, and then for GPT-4, December 2023. So it's not that far off, but we're in mid 2025 now, so 6 months ago. So 6 months, all the information that came out into the public domain, the LLM just doesn't know. It just hasn't been exposed to that. It just doesn't know what that is, right? But the RAG would know once you put it on your hard drive and train that system on that corpus of text. So that's it. I'm going to wrap it up here. Hopefully that was useful and informative and engaging, and as always, entertaining. Try to make these things pop and try to make it relevant to people, and deliver information and my results and my findings as I go through all these mini case studies and these little projects I build up for myself. I try to share my findings and drop the knowledge on you guys whenever I find something cool and interesting and worthwhile. So that's pretty much it. I'm going to wrap it up here. Thanks for your time and attention. Really appreciate that. And I'll see you guys soon when I put out the new video. Thanks.